Hello again. Welcome to another module video for Chapter 6, Mutually Exclusive Alternatives. And in this video, we'll be talking about alternatives with unequal lives. And these unequal lives can be handled a couple of different ways. Whenever we have several alternatives that we need to examine, the important thing is that these alternatives be examined on an equal footing, that they be comparable. Therefore, they must have comparable levels of service, uh, comparable service periods, so when they have equal lives, we're good to go. If they have unequal lives, we need our HVAC system we plan for 15 years. Well, one may have a life of 10 years and one may have a life of 25 years. And we need to compare those on the same service level. Well, there are really two ways to do this. The first way is that we can use a technique called cotermination. And cotermination says that we will examine these for a particular length of time, a study period, and we'll examine these for that length of time, and then we'll cut them off. For the alternative that may last 20 years and we're going to study them for 10 years, well, we will lop it off after 10 years. We'll get the data like we're going to dispose of it after 10 years, and everything will have a 10-year life. When we use cotermination, we coterminate 10 years in my example here, and therefore they all have equal lives, and that solves the problem. Then we can use the techniques we've already discussed: present worth, future worth, annual worth, incremental analysis. We can do that for those for the coterminated life. We'll talk more about that later. The focus of this module today is on unequal lives and a tool called repeatability. And let me say that repeatability sounds like nonsense, and it appears to be nonsense, but the good news is that first of all, everything we do is wrong. Everything is an approximation. We really don't know the cash flows. We really don't know how long something will last. So everything is really not correct. We want to make it as correct as we can. Repeatability uses the following assumption. That assumption is that we can repeat exactly the same alternative forever. For example, if we have an alternative that has a 3-year life, well, when that 3-year life is over, we can repeat that alternative for another 3 years, and for another 3 years after that, and another 3 years after that, ad infinitum, all the way to Neverland. And that the cash flows, the initial cost, the annual cost, the market value, whatever, those remain the same. So we just can repeat chunks of these cash flows over time, and time passes on and we repeat that same chunk of cash flow. And we can do that for all the alternatives that we're considering. So think of this. We may have an alternative with a life of 3 years. We may have an alternative with a life of 5 years. And we take the 3-year life and we repeat it 5 times. So 3, 6, 9, 12, 15. We take the 5-year life alternative and we repeat it. It's going to be used 3 times, 5, 10, 15. At the end of this, they have equal lives. We've gone out to 15 years. So then they're on a comparable basis. Then we could use all of the tools that we've used before: present worth, future worth, annual worth, incremental analysis, whatever that would be. We can use those same tools because then they have equal lives ultimately, way out in the future. And you can imagine that this can get a little bit difficult if you have one alternative that has a life of 3 years, another alternative that has a life of 7 years, and another alternative that has a life of 11 years, and you're comparing them. You have to go way out. You have to repeat these a long time before they get the same, before you get equal lives. So it would be at least, let's see, 3, 7, 11, at least 77 years. No, 3's not going to work. So it's the least common multiple of those lives is probably, 3 times 77, that's 210, 21, 231, something like that. So that seems a bit cumbersome. And it really seems, I mean, come on, doesn't that seem a little bit lame? That you can actually repeat these identical alternatives that long? Does technology not change? Do market forces and competition cause prices not to change? It's just, it borders on the ludicrous to assume this repeatability thing. However, it turns out that although it is kind of ludicrous and you would really never repeat these, it does provide a foundation, a consistent foundation that you can use to evaluate and compare these alternatives. So while it is wrong, while it is something we wouldn't really ever do, it does provide us with a sound basis for comparing alternatives that in general seems to work reasonably well. Let's look at an example. If you would, pull up the module spreadsheet and look there at module 3, that worksheet, and you can see we have, again, a MAR of 12%, and we have 4 alternatives, creatively labeled alternative A, B, C, and D. Each one has has an initial investment, excuse me, net annual revenues, a salvage or market value at the end of life, and useful lives are all different. And I have an IRR, so we could again eliminate alternative B from consideration should we wish to do so. And generally you like to eliminate unnecessary work, so we could eliminate alternative B right now, but let's not. So there we have it. And if we were going to assume repeatability, we would repeat these alternatives. Let me see, we have 5, 6, 10, and 4 lives. So let's see, the 5, 6, and 10, we could go to 30, but that's not going to work because the 4 we'll go into 30. So 40, no, 50, 60. 60 looks like it's the winner. So we would go out 60 years and we would repeat alternative C. We'd do that one 6 times, and D we would do 15 times. A we would do whatever that is, 14 times. Now, stop and think for just a minute. If we were to take, let's just consider alternative C for a moment. Take alternative C and just go out for 10 years and find the annual worth of those cash flows. Just find the annual worth for the 10 years. Well, as it turns out, if you were to take the next 10 years of alternative C, the same cash flows, identical cash flows again for 10 years, and you were to find the annual worth of those cash flows for 10 years, you would get the same annual worth for the next 10 years that you did for the first 10 years. And if you did it for the third 10 years and you found the annual worth, well, those cash flows are still identical cash flows, and you get the same annual worth for those 10 years. So as it turns out, the beauty of repeatability is that if we simply compare the alternatives using the annual worth method, and we find that annual worth for the life of each individual alternative, we can make a fair comparison. Because for alternative A, that annual worth would be repeated. We'd do that 14 times and it would be the same annual worth all the way out. And alternative B, we would do that 10 times and it would be the same annual worth every year whenever we repeated it. So that annual worth that we find is a very, very good tool to use to compare alternatives with unequal lives. Now here's the rule. The rule that we will use, that you will want to use in solving these problems is the following. If you have a problem and the alternatives have unequal lives, the first thing that should come to your mind, the first thing to think about is, I want to do annual worth. That's what I will use to compare these alternatives, is annual worth. And if you use annual worth, that will be fine if you can assume repeatability. It's the assumption of repeatability that's the key. So if the problem and the situation states nothing else and allows you to assume repeatability, then assume repeatability and do the annual worth. For this Module 3 example problem, if you look down to Step 3, I found the annual worth for each of these alternatives. And let me see, and as I state there, you can do this in several ways. You could find, again, you could do a cash flow table for each alternative, and you could do the net present value and then convert that to an annual amount for the respective years of each alternative. The way I did it is, again, I just used the PMT function, and because we have annual revenues, I used the PMT function to convert the initial investment and the salvage value to annual amounts. Remember, just by the way, kind of review from Chapter 5, remember that cash flow, annual cash flow represents just the initial cost and the final market value is called capital recovery. So what I've actually done here is the PMT function portion of each annual worth contains the capital recovery, and then I've added in the net annual revenues. Notice also that for my PMT function I put a negative sign in front of it because I want that cost of capital recovery to be reflected as a negative value as a cash outflow, which it naturally is. And we can look at these alternatives, and again I found the annual worth for alternative B. I didn't need to do that, but expectedly the annual worth is negative, so that value along with the same as the IRR being less than the MAR tells us that alternative B is not attractive. But we look at these annual worths and we select the largest one. And the largest annual worth here is alternative C, $6,401. So that would be our choice. We would select from this set of mutually exclusive alternatives, we would select alternative C. One other short comment here before I go away. If you look at alternative C and alternative D, notice that alternative D has a higher rate of return, 22%, as opposed to the rate of return for alternative C, 19.7%. Again, just to reinforce, looking at individual rates of return is not an appropriate way to compare alternatives. So we select the one that gives us the largest annual worth alternative C, and that's our solution for this particular module. In the next module, I will be discussing cotermination. For us, cotermination is really pretty straightforward because I would have to give you the information already that you need to find, with one rare exception, and that is when we calculate an imputed market value. And I'll talk about that in association with cotermination on the next video.